experiment we are going to see is glass slab. So we are going to see how to do the calculation. The aim is to determine the refractive index of the given glass slab. So you will be given a glass slab and a traveling microscope. So and a lycopodium powder, that is the apparatus required. So using that you have to calculate what is the refractive index of the glass slab. So the formula that we are going to use is the refractive index is equal to real thickness divided by apparent thickness of the slab. So as you can see from the diagram, okay, first we are going to measure the reading x1, okay, and then we will we will place the lycopodium powder here, and directly using the traveling microscope we are going to measure the reading x1, and then you will place the glass slab on top of it, and then you will view through the traveling microscope and you will measure the reading x2. That will be the apparent image that you are going to view from the traveling microscope. And then you will place the lycopodium powder here on top of the glass slab, and then you will measure the third reading x3. So you can see x3 minus x1 is the real depth, and x3 minus x2 is the apparent depth. Okay, so we will be dividing real depth by apparent depth. So as you can see in the table, you have to write the procedure and the diagram clearly, and you will mention in the formula x3 minus x1 by x3 minus x2 with no unit. This is very, very important. You have to write no unit here, and the reading x1, x2, x3 all must be measured in centimeter. You have to mention that it is measured in centimeter. Okay, now while doing the calculation, what you will do, you will draw the table. So first is serial number, okay, and then you will have x1, x2, x3, x3 minus x1 and x3 minus x2, x3 minus x2, and then the refractive index x3 minus x1 divided by x3 minus x2. So this is the formula that you will be using, okay, and the readings will be here. Usually the one that we have in our lab is the real depth is around 2 centimeter and the apparent depth is around 1.4 to 1.3 centimeter. Okay, so when you find the readings, you have to make sure that you get the value, the average around 2, and this one the average around 3 or 1.3 or 1.4. Okay, so how do we start doing the calculation? So the first reading is random. You can choose any point. So one thing here, we have to use the second decimal also, but here for simplicity purpose I am not going to mention the second decimal place. Okay, so 3.9, and the x2 value is 4.6, this is 5.9, and here second reading, the first reading is at any random place. Okay, so you can start from any one point, and then from there you will be measuring x2 and x3. So 5.6, 6.4, 7.6, and then 7.4, 8.1, 9.5. So then you will write x3 minus x1. So 5.9 minus 3.9, which is equal to around, I told you, it is 2.0, and then x3 minus x2 is around 1.3. Once again here 2.0, 2.1, 1.4, 1.4. Okay, so once you have done this, you will come to the calculations part, and you have to do the calculation for each reading. That means what? You have to take the mu value for each reading. So for each reading, x3 minus x1. What is x3 minus x1? 2. So for the first reading, your mu value will be 2 divided by 1.3, which is equal to 1.53. Okay, so here I will write 1.53. And then for the second reading, mu is equal to 2 divided by 1.4, that will be equal to 1.42. Okay, so here I will write 1.42, and then for the third reading, mu is equal to 2 divided by 1.4, so that is 2.1 divided by 1.4, that is equal to 1.5. Okay, so here I will write 1.5. Okay, and then you have to take the average for these three values, because what is the real depth you have to show, what is the apparent depth you have to show, and what is the average value of the refractive index. Okay, so the real depth average is around 2. Okay, so 2.05 maybe, so you will get 2.1 when you round it off, and then here 1.4, and then here 1.5. Okay, so we are rounding it off to one decimal place, as you can see. So these values will be written in centimeter, whereas this will have, the final reading will have no unit because it is refractive index. Okay, so finally when you are writing the result, you have to write three results. So the first result is real thickness of the glass slab. What is the real thickness? That is 2.1 centimeter, and then this is 1.4 centimeter, and the refractive index is 1.5, no unit, with no unit. Is it clear, student? So this is how you will be performing the calculation for the glass slab.